font is really small. I have trouble. That's funny. Oh, that's probably why I don't self-type and then I got better fingers. You're like, oh no, all the backspacing. I'm so inefficient. All right, I think we should do this thing now. Are you ready? All right. Are you YouTubing it? Great. So, are you guys ready for the solution? You guys just learned the object-oriented way to do things, but there are really two ways. But you could do the sort of procedural approach, or you could do the object-oriented approach. And just for the remaining skeptics, I'll tell you that the way to do it in Python is object-oriented, and everything you've been doing in Python so far actually has been using object orientation. Everything from instantiation, so like when you create objects and you have a function that creates some object, you've done this with a number of things. Types, you know, whenever you've created a number and you've said like, what's the type of this type, and then you check and it maybe gives you an instance type. And methods here, all of the methods that you've been using that are associated with the modules that came from your modules lecture the other day, these are also fundamentally object-oriented just in base Python. So you're either going to like use that native object orientation or not. And like one way is easier. So use object orientation. So let's talk about the way that you would do it if you were naively procedurally attempting this exercise. So you were supposed to create a function that calculates the perimeter. And like you and I both know, polygons are defined by some set of vertices. So all you have to do is feed the vertices into a perimeter function, write a perimeter function that takes any set of vertices and turns it into a perimeter, right? And that's great. And it's the procedural way, though, so it's not really doing it in the object-oriented way. But I'll go over how that works, and then we'll go over what the right way is. So the way that you would do it is with an import math here. And then if you wanted to add some object orientation to it, you could, instead of receiving vertices in this parameter, you could say, I'm going to receive a polygon. But let's go on. So the procedural approach imports a math module, and then you might have some perimeter function that accepts a polygon object. And that polygon object is defined by a list of vertices. And polygon, you know, to you is actually just a list rather than an object. And so like your procedural approach would start with the sum, and for each object in the each item in the list here, you would then go through and take the square root and get the distance and add it to the sum. But really this polygon would be better if it were a real object rather than just a list of vertices, right? So you've written this function to accept a list of vertices. Here you're calling it polygon. Perimeter, list of vertices equals some number, right? So that's the sort of naive way to do it. And you can use notions from this naive way to do it to instead of this argument named polygon, and here's your doc string. Sorry, I should have been typing through these. You would grab the adjacent vertices. Remember, you have to divide by this list index exception. Anyway, so I should have gone through these slides. I didn't write these slides, but anyway, the next thing you do here is increment the distance variable and return the value of sum and do the unit square here. For a more complicated, so for the unit square, which is 0, 1, 0, 1, right? You get 4, which is the right perimeter. For a more complicated polygon, you get this like 17 number. So you can do the same thing with a perimeter function that does the exact same thing that class approach, then it's like more beautiful to execute. You can say A equals a polygon, and then you give it the list of vertices, and then you say the perimeter of A. You say A dot perimeter. Yeah. Mm-hmm. A list, yeah. So what this vertices equals does is it says that the default if you don't supply some list of vertices, is an empty list. Right. So it has no vertices. So you can initialize a polygon without a list of vertices and then initialize its vertices later. So that's what sorry, the question was, what is this equals sign up here? In vertices equals empty list, and what it means is that there's a default value for vertices, the parameter. And if you don't give it any vertices, it will assume it's empty.
Just a quick note about having an empty list as a keyword argument, so that could have potentially unexpected effects to modify it, because that is actually a global variable.
Yeah, so it's been pointed out that by virtue of having this keyword argument with a default value of an empty list, it can have unexpected results because it becomes a global variable within this class. So, well, at least within the function. Anything else? So I went through that kind of fast, but I encourage you to go to the schedule here and download the IPython notebook. Whoops, the schedule here. And download the IPython notebook. There's a number of forms of this solution that have been listed on here. So you should be able to see those if you refresh. So that'll be right here, right? So you can see it in a .py file or in an IPython notebook. All right, does anyone know what's next?
Yeah.
We're 20 minutes, okay, good to go. Boop.
Thanks. And just a matter of parlance on object-oriented stuff. When we said A equals bear, and bear is a class that we've defined, we are creating an instance of bear in the form of A, and we call that process of the creating of an instance instantiation. And so when I do the next lecture on object-oriented programming, which comes after our special lecture from GitHub, you'll see a bit more of that, and you'll see what it means when we're essentially creating instances. So without further ado, let me introduce Tim Clem. He's an employee at GitHub. He grew up programming Logo and won some major Logo programming contests as a child, and then realized that was kind of weird, and then he started programming in BASIC and became famous for writing code without the goto, which was pretty impressive. And he's a very good friend of Fernando and ours, and we're very happy to have him here, both representing sort of his view of, I guess, Python, but also, more importantly, his view of versioning code and GitHub.
It's on this side here. All right, how you guys doing? Sitting down a lot today, huh? My name's Tim Clem. I'm an early employee at GitHub, and I'm going to try and take a little bit of a different track from what you guys have been talking about so far. You probably won't see any Python code in this presentation, but I was hoping to give you a little bit more of maybe an industry perspective, kind of specifically around how code is built in the world of open source, and a little bit about how GitHub works and kind of the way that we tackle problems. And I think a lot of these ideas all center around the pull request, which is something you may have heard of. GitHub didn't really invent this, but I would say we maybe popularized it and made our own little twist on it that has some pretty profound effects on the way people write software today. We kind of had this idea that it's better to work together, and you might find yourself that you don't actually do this often, but this is sort of the great invention of the web. And what's fun about working on GitHub and working in open source is that you find by yourself it's often very easy to work alone because you don't have to communicate, and you don't have to collaborate, and you don't have to talk to anybody else. You can just push whatever you want and write terrible code. But we really think it's better to work together with other people. And lots of people like to point to the current internet, and you kind of have the social web, this world of likes and faves, of hearts and props and stars, and they kind of think of this as like working better together. And I sort of want to kill that premise off a little bit because I don't actually think that that's working better together. And I'd love to see the social web sort of evolve, maybe not go away, but at least change. And what I'd like to see in its place is something that we kind of talk about as the collaborative web. And so the collaborative web is not this passive consumption thing. It's about sort of actually working with other people to build measurable stuff, to change the world in some meaningful way. And GitHub really as a company and as a product is all about building better software together. So the number one way that I think this happens on GitHub in the world is something that we call the pull request. And this is a little bit of a funny moniker. The basic premise is that there is some project out there in the world, there's some piece of code. Actually, people use these for things that aren't code as well, which I'm going to show you a little bit later. But you want to improve it for some way. And traditionally what you would do was maybe you would ask for permission to join the project, and you would say, hey, I have this idea. I think it could be better if you did this on your website, or if the Android kernel did this. And then you wait, and then you have this discussion, and then maybe someone says, okay, you may have commit right to this project because we think you're kind of nice looking and you might write good code. And the pull request sort of turns this all on its head. And so the pull request is very much about writing code first and asking questions later. And it a little bit like flies in the face of some of these ideas in that you don't actually ask if you can do something. You just start doing it. If you have an idea, you start building it. And the pull request is that moment where you choose to share that measurable piece of work with someone else. That's where you decide to start working together with other people. And so I like to think of them as sort of like a conversation that starts with code. And I think asynchronous is a key word there as well, in that I don't have to live in the same city as you. I don't have to be in the same time zone. We don't need to be sitting next to each other in the same room. But we can work on this thing together, but it's something measurable. It's not just an idea. So I always love to share this. This is actually, I zoomed way out. It's kind of hard to see. This is actually a real pull request. GitHub uses GitHub to build GitHub in many ways. So almost all of the features on the site start off as pull requests in a repo on GitHub that we then push to GitHub. I know it's very, very fun, very confusing. This is actually a pull request zoomed way out. You can see you would have to scroll many, many times to that changes the About page on GitHub. And so someone came in and they said, hey, our About page is feeling kind of dated. It doesn't really show who works here anymore. The language is off, et cetera. And they basically made a new proposal. You can see sort of in the upper left-hand corner there, they were like, what if we had like this Octocat floating in space? And what if we had this, you can see there's like a wall of text up there of like the mission of GitHub and all these things. And then this conversation ensues. And this conversation isn't just chatting like you might chat on a Reddit thread. It's interspersed with measurable changes to the code base. And it's not any code base. This is actually github.com. Like this is real code changing in a branch of GitHub. And people are sort of talking about it. And they paste in new screenshots and they say, oh, wouldn't it be great if we put all our employees up there, all their faces? And what about this? And then some guy comes in and he says, what if we make the little Octocat astronaut like float around parallax when the accelerometer on your phone changes, and someone else is like, oh yeah, we can do that with a mouse too, and it goes on and on and on, and eventually this thing, someone merges it, and so sort of the key moment in a pull request lifetime is someone merges it into the main line, and to us that means it goes live, it goes out into the public. If you merge something into master at GitHub, it immediately goes out to the public as long as it passes sort of our build system, our CI server. And so this one actually did. It was merged and went live. One of the really key elements about this is that this is a process that has a URL. And I talk to people a lot about it, and it's interesting how in a lot of business and even in university, this is a really foreign concept, that to us, like, things aren't real at GitHub unless there's a URL. And having a URL means that I can share that with you, that we can have that conversation in public together. If you send me an email and I respond to you, and then some guy starts next week, there's no way for him to be in on that conversation. But if we do that same process with a URL, whether that's a discussion on GitHub or whether that's on a Google group or whether that's some of the other myriad of forms of public communication that have a URL, that thing now is there forever. And I can share it with someone. I can go back and look and see how it got there. And this is really the killer feature of a pull request, is I can look back and say, why does our Octocat have this crazy floating, why does our About page have this crazy floating Octocat on it? And I can look back and see why that is. They also allow this idea of collaboration without coordination, which is huge. Because often to collaborate on something with someone, you actually do need to be in the same physical place. You need to be living in the same time zone. You need to sit next to each other. And so to do that, you can actually work on something together without a lot of these traditional forms of coordination. So to us, this means a few things. Number one, we like things to be electronic. And to us, the phrase we use is avoid meat space. If you haven't heard that term, it's kind of a programmer hacker thing. But We're all like bags of meat. Meat space is like what we're doing now. This is a physical place. I know these are being recorded, and so I think that's great because part of the output of giving this talk will actually be a recording that can also be shared and talked. And so that's a great way to get around sort of meat space. But I think I would caveat with say make FaceTime count. And we've sort of found that the division here is that FaceTime is really valuable when you're thinking big picture, when you're talking about strategic stuff, when you don't know which direction you want to run. But as soon as you have some very specific goals and stuff you want to implement, then it's time to dive into some of these electronic asynchronous forms of communication because you open up this whole new world of the kinds of people that can contribute to your efforts. And in this, we've sort of repurposed our office. We don't want to build like the Google campus of Office. We don't want our employees sleeping at the office and never leaving the office. We feel like it's a good idea to go home. We actually specifically don't bring lunch into the office every day because we like people to be out in the community and at the local restaurants. And so the office becomes less of this place to come to sit next to someone and work on a project together, and more just a place where maybe you got a little nicer chair and a faster internet connection so that you can do your job better. And even as we've grown bigger, we've sort of decided that our office strategy is actually to create a network of offices all over the world, wherever our employees already live. So instead of building this like monolithic campus in Palo Alto, we're going to go ahead and build, I don't know, maybe a few hundred GitHub offices all over in different places, wherever employees end up wanting to live because they've self-selected for various reasons. The second thing we talk about a lot is just things being available. And sort of the second half of stuff having a URL is that you end up having these very open, transparent conversations, whether it's about code or whether it's the way that you run your business. People can understand how decisions have been made. And then this idea of stuff is asynchronous. You know, don't disturb me. Like if I'm in the flow, if I'm focused and concentrating on getting something done, you don't need to come tap me on the shoulder. Send me a message, send me an email, open a pull request. Though I will get those things later. It's often not important for me to break my concentration to address whatever it is that you have come up. And if you get in this habit of having this asynchronous communication, it becomes easier and easier for people to actually focus on the things that matter to them on a daily basis. And then finally, to kind of bring it full circle around, is this idea of stuff should be lock-free. Like things should operate like a pull request where you don't actually need to ask for permission in order to get something done. You should maybe ask for forgiveness or ask for it to be merged later on, but you should be able to change things, and that's change things in code. We don't block people from changing the GitHub code base. You don't have to earn. Anybody at GitHub can change the GitHub code base. Anybody can deploy the GitHub code base. And finally, I think a lot of this we sort of love to talk about. If you don't know Hubot, he's sort of our company robot. He's got varying levels of intelligence depending on the day, but we run a lot of the company out of chat, and our chat room is a place where this robot kind of does your bidding. It's almost like having the command line in a public forum. So if there's some sort of production issue going on and the servers are melting down and one of the front ends is having problems, in a traditional company, some ops guy would be sitting behind his terminal, wizarding away at his command line, to fix whatever the issue was, and nobody else in the company would be able to see what he was doing. The way we run the business is that activity actually happens in chat. And so you say, Hubot, show me the load on the front ends. Deploy code here. Take this front end out of the load balancer. Show me a graph for the number of incoming connections from these IP address range. And those graphs and those metrics all come back in the chat room. So the guy that started this week on operations can actually watch how that problem was solved. He can learn and see and listen and understand, okay, here's what's going on. And if you just happen to be a developer working on a different project, you can go sit in the room and say, oh, okay, like something's wrong, but people are working on it, and this is what they're doing to fix it. So it's a very interesting, it's a very different paradigm shift for how to communicate about things and how to run a business. So finally, I think it's probably I want to just basically show you a little bit of GitHub and maybe even create a pull request or something fun like that. So let's actually, my calendar is not very interesting. It's mainly too busy. I'm going to get out of staff mode here. What I want to do is just sort of basically create a repository and kind of show you like how we function on GitHub. I'm going to actually purposely stay away from the command line here as much as I can and just kind of give you an idea of like how the features work on the website and how this collaboration model actually functions. So a repository is sort of, you can think of it like a folder on your computer. It's just a place that you would start a project. It holds a bunch of code. You can take an existing repository and push it up, or you can create a new one on the site. So maybe we'll call this one Bootcamp. Most repositories are anchored with sort of your username. If you're a member of an organization, like I could create this under the GitHub account or one of these other organizations that I belong to. And then, descriptions is just people are going to find this in our search engine and that kind of stuff. So it's kind of nice to tell everybody what you're up to. So, and then in this particular case, I'm going to make it public because it doesn't really matter. And then we can initialize it with a README. We do give some sort of help for licensing. We kind of care pretty deeply about open source licensing. If you haven't seen this, we have a really cool site that we just launched, which sort of helps laymen understand open source licensing and make a great decision about like, what is it you're concerned about? If you don't have a license, you're falling under like default copyright law, and you probably don't realize that you're actually making it very difficult for people to collaborate with you. So this kind of stuff is actually pretty important. I'm going to go ahead and just maybe add the MIT license because this is my favorite in there. And then we can create the repository. So this thing is now, it's just a blank repo. It's like a folder on your file system. I can get it locally if I want, but I'm actually not even going to go that far. You can see that a lot of repositories, it added that license file in there for me. And a README is a great chance to sort of tell people, what is this project? What does it do? Why are you interested? Maybe they're coming here just to consume it. Maybe it's a library and they want to pick it up. Or maybe they're coming here to be future developers. Or maybe you can give some sort of guidance as to, if you wanted to dive in and help, these are the areas of this project that need help. You'll find this on many repos across GitHub. But what I'm going to do today is sort of an interesting thing, is I'm going to go in here and I'm actually going to demonstrate sort of, I think, one of the lesser known but more interesting features on GitHub, which is we have this thing called pages, which is basically you can have a special branch on any repository, which is a website that we host for you. This is sort of an amazing feature. We're going to bootstrap this. I'm going to sort of leave all the default stuff in here. You can put whatever it is. If you want to do some analytic tracking on it, we have a bunch of custom designed themes. All this does is generate a bunch of HTML, CSS, and JavaScript that you can then customize yourself. Slate's pretty awesome. I think maybe we'll stick with that one. And then it shows you is now basically this is a website that we're hosting for you. It might take a moment here for the servers to pick it up and run, that you can put whatever you want on it. And I think this is a great place to start with sort of like talking about how pull requests work at GitHub. So this thing lives on a special branch called GH Pages. And so you see if I switch to this branch, there's a whole different set of things going on in the project there. So branches are like alternative views of the universe. You can do anything you want in a branch on GitHub. You can delete all the files and put new ones in, which is what's happened here. And on this thing, I'm going to basically try and follow entirely the workflow that GitHub uses, which is that the main line is always deployable. In this case, it's the GH Pages branch is the main line I care about. And so we're always going to create branches off of that. So I'm going to say update copy. So let me create a branch that is going to sort of specifying my intention here. So I want to do some work. I'm going to create a branch in order to do that work. And then on this branch, I'm going to come in here and maybe let's just edit one of these files. So go here, there's a bunch of header stuff, and look at all this stuff. This automatic page generator, I don't think I really want to tell everybody that I used an automatic page generator. Welcome to the Python bootcamp. Go down and commit changes. So a commit is just like a save point. You'll see this on the command line as well. You know, this is nothing more than like I want to make sort of a history entry, like I'm saving a version. People often do this with files in their inbox, or underscore v1, underscore v2, and that kind of thing. And then if I go back to the root of this project, you can see here that there's sort of an immediate hint that like something has changed on this branch, and GitHub is sort of offering to like let me open it up and see what the comparison is. So I want to do compare and pull request. And for the purposes of this demo, I'm actually not going to merge it into master. I'm going to merge it into GH Pages. So we can see here that as I'm considering proposing this as a change, so I'm considering sending this as a pull request, we can go down and look here and say, okay, what is it that this person is actually changing in the code base? So what you're looking at here is called a diff, short for difference. The red is stuff that's been removed. The green is stuff that's been added. And very obviously, it was only one line that I changed in the project. And this has looked pretty good to me. So generally in this, you sort of think of this like an email. There's a subject, so I'm someone's going to read this. It's going to come into their inbox, and they're going to come back here, and they're going to sort of evaluate as to whether this change is beneficial to them or not in their project. So I'm just going to sort of say something like update homepage for my new site. And this field that I'm typing in is sort of an interesting field. You've probably seen a little bit of this with the IPython notebooks. It's a markdown field, so you can preview what it looks like. And some of the advantages here is it lets me actually do things like @mention people. So I can talk about my friend. Oh, I don't have anybody in my repo here, I guess. So, or any issues at this point. So this is a place where you can write a whole manner of things. So here's a heading and some of my other text. And then this stuff, so you can sort of give sort of a nicely formatted way for describing what this particular is. And then at the end of the day, you say, let's send off this pull request. And at this point, other people are going to come in and sort of review what it is that you've done. And they can do so by commenting online. So I can say, you know, key to this change, heart. Comment lines. People will have this discussion. And in the beginning, when I was talking about like pull requests are a conversation that begins with code, you can see sort of what this means now a little bit, and that we might go back and forth. And I might come in here and I say, oh, like, I don't actually like what you've done with this. And I can continue to make changes and push commits to this branch, to this pull request, until everyone is sort of assured that this is the thing that they want to do and that they want to pull into the workflow. So at a certain point, I'm going to say, all right, like this is looking pretty great. Like, let's pull this into the project. And you can pull this down and do this locally. You can pull it up in one of our native applications. But if you have automated CI like we do, we can just merge this pull request. And so this pull request then got merged into GH pages from update copy. And if I go back to this site, to the boot camp, as soon as our servers sort of run themselves here, we should eventually see that this particular page is updated. Maybe. It'll email me when it's done, hopefully. Oh, there you go. Demo Python Bootcamp. So that's all I changed, right? And everything else stayed the same. So sort of once, you know, two sort of interesting things here. One, there's a pretty easy way to create your own website on GitHub. And actually, you own whatever your username is, .github.io. You can have that root site as well. And then all of your projects are just, you know, / whatever the name of your repo is off the end of it. So you can tack those on there too. Finally, I want to just show you what a real one of these looks like, because I think like the demo is interesting and all, but it's obviously a little bit of a contrived example. Yeah, go ahead.
Just when you were like committing and except when you were merging, you said you could pull it offline. It's a little bit confusing to me, the difference between GitHub and Git maybe.
Sure.
And so like, what do you mean pull it?
Absolutely.
Merge it on your personal, you know, what does that mean?
Yep. So. Absolutely. So the question was, it was a little bit confusing as to the operations that I'm doing on the website versus what it means to pull it locally and deal with it and merge it. So honestly, let's do just that. So with this, we can easily clone this web. So it's just tclem bootcamp. You'll forgive me a little bit of command line trickery here. I'm going to. Yep. Is that good? Did everybody see that? Plenty. All right. So I have a couple of local utilities that allow me to maybe get clone. So let me show you where to get. So from the root of the project, you can always clone the entire thing down with this URL. So the command is just get clone and then the URL, and that's going to take that bootcamp project and put it locally on my computer. So if I go in here and bootcamp. This is identical to what you're seeing on the web. Now you notice that this is the master branch. So I took that same project that was up on GitHub, and now it's on my local computer, and I'm on the master branch, which means what? I've got this README and the license file that we decided to put in there, and you can see that the license is indeed the MIT license. So if I run git branch, it'll show me that I only have master, but those are only my local branches. So if I run git branch -a, I can see that on the server, there's this update copy branches and there's this GH pages branches. So let's check out that GH pages branch. Checkout, I have CO as an alias for checkout. And if you just give the branch name without the origin, Git will automatically set up a local branch to track that remote one. So now what's interesting is if I go back to, remember my Finder here we were looking at before, remember how it just had the license and the README? Since I've checked that out, now I actually have the full code that's on that GH pages branch. So we can open this up in VI, and you can see that now we're looking at this full little website that's being deployed up to there. So this is where I could then actually make a further branch. So I could say get checkout minus breed, more updates maybe. And then we can come back here and so it's called, we'll just keep changing the same so that it's obvious what my changes are. So now you can see it, same as on the web, I've made a small change, but I've only done this locally. I haven't shared this with anybody on the world. No one can see this yet. So I can add it and commit it. And I can push that branch up to GitHub again. So if I go back to GitHub and refresh this page, you're going to see here's another one, more updates. So let's do a pull request. Remember, once again, I'm working off of this GH pages branch. And now we can see that locally I made this change. And I can go back to my local system and switch between those two branches and get sort of a feel for the various content, or I can see the differences between there. So if I was working on a more complicated thing, so and let me show you that now. So this is actually a pull request on GitHub itself. This is a buddy of mine, Kobe, who is implementing a new feature on the website. So he wants to add a new portion to the UI, which lets you add files directly from the GitHub UI without having to go locally to your computer and push it up. And so he's done so by doing a little bit of work and opening a pull request, but he's got a lot of questions, and he sort of says, like, currently this is what it looks like. You know, I'm thinking maybe we should put a little drop down in there, and we should have like both view history and new file under the drop down. And he says he takes a stab at the logic. Kobe's a designer, so he's got some dev skills. And then if we go look at the code here, we can see these are all the files that he changed in order to implement this feature. And it's everything from changes in Git RPC, which is sort of the like backend layer that we use to talk to file servers, to looks like Rugged got removed, which is a Ruby library for libgit2 access. And then there was some JavaScript changes and some SCSS changes. And so these are all really the like actual code changes that went into making this feature happen. They have a little bit of discussion. When these come in, added a commit. This is sort of like his contribution is he's changing code. And then people come in and they sort of say like, yes, this is great. Like, I love that this has happened. And then they check it out and they play around with it a little bit. Other people come in with like, what about these pages? Are we forgetting about these other places? And maybe we should have like an icon-only tooltip button. So people sort of have this conversation about how the feature is. And if you were a developer and you wanted to play with this locally on your computer to see what it looked like, you would do just what I did, which is you would go in here, you would clone GitHub, and you would say, you know, check out whatever the name of the branch is, and then run it locally to sort of see how that version of the code was different than what was currently deployed live to GitHub. So I would love to answer more questions. I know it was a lot of material there. As long as I have, please keep asking. So.
When you hit push, it was from phone, what if you initialize in your local, can you click push?
Absolutely. So if you go the other way, repeat the question, yep. If you go the other way, so the question was, if you clone and then push, can you go the other way where you initialize it on your own computer and then push it up? Is that correct? Is that what you're asking? So you absolutely can. So that's as simple as another boot camp. Initialize an empty Git repository. If you go to GitHub, we'll help you. This is a great way to like, I'm just going to name it the same thing here to make it easy to match. Public, doesn't need a README. I didn't initialize it. Maybe if I can click on the button. And we're going to give you some instructions here. So you can, if you use GitHub for Mac or GitHub for Windows, you can click this button and we'll set it up for you locally. If you already have a repository, and let's go ahead and touch README. So we have something to put in there. You can sort of follow these instructions, and then this is the key line here. So instead of cloning, I still have to add, so git remote add origin. So I still have to add GitHub is the place that I want to push. And then the full command is git push -u so that it's going to track. And then that's going to go up here. So if I come back to GitHub and refresh this page, it's now going to have that code that started locally on my computer. Does that answer your question?
And how does it know like which user put it, like which user on GitHub?
So there's a couple of different ways. The first way it knows is that I have SSH keys set up on my computer. So I have previously gone into the settings of GitHub and done that. The other way it knows is that because I have done this before, and actually I used an HTTPS URL here, so there was no SSH involved. If I had not already authenticated with GitHub, Git would actually prompt me for my username and my credentials. There's a credential helper that does that. That's part of getting set up. So it knows who I am and knows where to put it. Other questions? Josh?
Just say a few things about the use of GitHub for projects other than code-based, sort of writing papers, data.
Absolutely. So the question was, will you say a little bit about the use of GitHub for other things other than writing code? As a whole, we've really tried to keep the product pretty focused on developing software, but we think that's a fairly broad topic, so we sort of envision that as accompanying everything from like the design to the actual coding and construction to releasing software to documenting software. So all of those things in our mind are sort of what the product should be focused on. Even so, we've had a lot of people actually just use GitHub for other interesting things. So there are people who are doing things like tracking the US tax code. So every time it changes, they make a commit and you can go see like what's changing year over year. There's a whole, I don't know if it's a state or a county somewhere in Germany that's basically like keeping their legislation up to date in GitHub. The White House has been using GitHub a ton for sites just like this that they then publish to their constituents to gather information and do sort of various interesting things to sort of help the government better communicate with people. But the sites are open source and they're on GitHub so that if you find an error or if you want to propose something else that happens on the website, I was very proud. I think it was a couple of weeks ago, someone shared with me he's like the CIO of technology at the White House was merging a pull request and he used like an American flag emoji before his like 4-line signature of all his official titles of US government president. So we've had people release music albums on GitHub and sort of like collaborate on music tracks. I can't say that our diffing ability for music is very good right now, but it's definitely an interesting thing. We do diffing for images. If you search for like image diffing GitHub, you'll probably end up on one of these posts. So if you put in 2 images into a repo and you change one of them, when you go to your pull request, you'll actually see a page like this where this is an example of an image that was shrunk down from 300 by 300 to 200 by 200. And you can view it in a variety of modes, 2-up, swipe, onion skin, or actually like, I think we do like the actual mathematical difference of the two to sort of see what's changing in your images in the code base. We have a lot of stuff that people are sort of working on in the 3D rendering space. So if you work with like STL files or any of the like 3D file formats for printing and those kind of things, a lot of those files are starting to be able to render on GitHub so you can see what's wrong in them. Hopefully maybe there'll be some diffing support at some point for that as well too. Our lawyer, we actually have an in-house lawyer at GitHub. Finally, we got big enough to have that. And he actually writes most of his legal documents in a repo on GitHub. He keeps a GitHub legal repo, and he accepts sort of corrections to things like our terms of service and that sort of aspects of it. We've had a couple people write articles about GitHub in publications where they've actually put the entire article on GitHub, and then at the end of the article, they've basically let their readers do spelling corrections, etc. One of them had a very interesting result in that the article was actually translated by the community into 25 different languages after the publishing of the article, just all through pull requests as well. So sort of, there's a variety of things that you can do. Certainly nothing holding you back, but I think we'll, for the near term, stay pretty focused on software stuff. So. And we did the peer review using the pull request machinery. It worked very well. Yeah, we do it for our blog posts too. Like public blog posts, we'll open them as pull requests internally so people can sort of comment on them and fix issues with the post before they go out live and that kind of stuff. Some guy organized his entire wedding on GitHub recently. It was in the news. I don't even know what that means, to receive invites as issues or something. I'm not sure what he did, but anyway, all the way in the back again. GitHub and Bitbucket, the difference between GitHub and Bitbucket. Honestly, there's some very similar products. I would say GitHub tends to be a place where people are going to build their reputations in the community. Bitbucket has always sort of valued like free privacy, which in my mind, GitHub, it isn't something we value. We value open source, and if you're going to be private, then we charge you money for it, because that's how we run as a business, and we sort of feel like those two things are a little bit of a trade-off. Like free privacy isn't doing anything for the community at large, and it isn't doing anything to help us run the business. So there's sort of some semantic differences. I would say Bitbucket also really embraces like Mercurial and all these other various ways to work. It's sort of the like solution for everything. GitHub is a very opinionated product in that we sort of feel like there are specific workflows that we really want to enable people to do, and that we think really promote both open source and just better collaboration in software in general. And so we tend to stay pretty focused on those core workflows and features. So it's also our primary business. Bitbucket is like a loss leader for Atlassian, is the big company that owns that product. So it's something that they give away basically to bring people into the rest of their expensive product suite. So. It depends on the kind of, so the question was, would you not recommend GitHub for private project management stuff? It depends on what you're doing. We sort of exclusively use GitHub as a private product management tool inside GitHub. So it serves our needs, everything from legal to HR to code and software to documentation, basically everything we use to run our business. Certainly, I've talked to a bunch of people. I mean, people get fairly excited about their very specific, like, Agile, or there's a whole variety of ways that you can sort of project manage various teams of people. We're pretty hands-off on a lot of those things. We don't have a huge management structure at GitHub. People sort of get to choose what to work on, and we don't have any policy on time off or vacation days, or we don't care when you work or what you work on. So we don't have a lot of like oversight, so the product doesn't have a lot of those high-level features in it as well. There are a lot of things that do that. We have a huge amount of integrations, so like there's a API and service hook layer on GitHub that people use to tie into a lot of those other systems if management really wants to run like a hard-nosed Agile system or like a very waterfall strict software development process. So those are options as well. So Fernanda.
Can you mention your EDU stuff?
Sure. So we do give away and discount GitHub for Education. If you're a student, you can have a free micro plan, which gives you some of those private repos. So you can have private projects and maybe do things like track command line scripts you're not ready to share, or private dot files. So that's definitely something you can do. If you're a teacher or you run like a student organization and stuff like that, all you need to do is basically send us an email and sort of prove that you actually are a student, and we give discounts and free accounts for various things like that. So github.com/edu, find out more. Ultimately, what you're going to be doing here is basically sending us an email. Oh, I'm already a paid member, so I can't also have a free discount, but it will change for you if you go there. Anyway.
What's Git's view of storing like data on Git, like large data?
Large data. So the question is, what's Git or GitHub's view on storing large data? Git is really optimized for code. It does an all right job with binary assets, but if you're going to check in like feature length film or video files, the problem is you will just see performance degradation for it. I really feel like a lot of those assets probably belong outside the repo, or at least there needs to be another creative solution to link them in, because they don't often change or version the same way. It's difficult to look at like 2 copies of even a short video and film and say what's different and which one should I choose. So there's not a lot of value necessarily in having those versioned in a Git repo. It's definitely something we've talked a lot about. We would love to do a better job, especially with like gaming companies and other organizations that are incredibly asset heavy. Many of them are still on very, very old school technology that they've highly customized to handle those sort of large asset workflows. And I would say Git and GitHub are not overly optimized for it. We certainly have people with massive repositories that work just fine, but it isn't what we're gaming for right now. So.
Yeah, is the core GitHub software public, and can anyone make a pull request to it?
This is a great question. So the question is the core GitHub software public, and can anybody make a pull request to it? It is not. So I would say maybe 50, 60% of the stack actually is public. Most of GitHub is built on open source technology, from Linux to Git to a variety of tools and things that we have developed and put into the open. Ultimately, we still are a business, and we feel pretty strongly that like we actually want to be a business and we want to make money, and we want to do so in a way where we feel like we're contributing to the world. And that is how that's how we pay people's salaries. We've always felt very strongly about actually building a business that isn't dependent on ad revenue and is actually a product that people want to buy, as opposed to sort of selling other people's time to third-party companies, et cetera. So we pride ourselves, and we like to have a direct relationship with our customers, and it's something that we'd like to continue doing in order to keep sort of our vision for the product sane and in a similar direction. So, other questions? Yeah.
Sort of more of a Git question, I guess.
Yeah.
If I commit something just on my local computer, if I don't have a GitHub account, or if I haven't told it to talk to the internet, where does it go, or is it saved?
It is saved. So when Git is always almost a two-step process. So the question was, when I work locally, where does it go? When I make a commit and I'm not connected to GitHub, where is it saved? Where is it saved? What's the difference? Git is entirely, you don't even have to use GitHub to use Git. So you can start a repo on your computer and never share it with anybody. And all that gives you is the ability to basically make snapshots, to make versions. Those versions all live on your computer. And if you go into, so we're in this another boot camp here. And if you do like ls-la, you'll see there's this .git directory. And if I go look at what's inside there, we can see that inside this .git directory is basically a little database. And this database is what's tracking when you make a commit. Git is basically writing that commit structure into this database. So it's an object database. Things get turned into binary objects and actually compressed down on top of each other. You can go look in a lot of these files. There's not a lot of rocket science going on. Most of these are basically text files that if you want to just poke around, open them up in VI, cat them, you can understand pretty quickly like how the internals of Git work just by looking there. So that stuff is all saved locally, and that's what's happening like when I, see I have a README here, and when I switch branches and the structure changes, so we can go back to the bootcamp one. So we have all this stuff. When I do git checkout master, and now you can see like there are different files in there, it's going to that database and it's saving off the current state, and then it's pulling up this new branch and it's writing it into the working directory. So it's sort of like a little stash file system that you can put things in and save off versions to. You have to choose to share that. So you have to connect up to a URL, whether it's GitHub or whether it's another Git repo. We can do it peer-to-peer. We don't need to be on a network. You and I could work together on a Git repository. Or if GitHub's down, you could push it to Bitbucket, or et cetera, et cetera. It is up to you to decide to share that repository with somebody else. Does that help? Yeah. Time for more? Or? All right. Thank you.
Thank you. Thanks. So we're going to jump right into the object-oriented lecture number 2. All of the material should be up there already on the lecture website. Okay, good. Thanks. Yeah. You can see it? It's coming in now. So just a couple things I would add about Git and GitHub. What you see here is one of those auto-generated pages for the Python computing class, which starts on Thursday. And so I use this basically as kind of the intro slide, but then all the content is here. So students will be able to basically do a Git pull and get all the lecture material. What we haven't done here, because it's actually a pretty heavy boot camp in terms of the amount of commits we've made and the size of the data, because we have been pushing a lot of data around, is the bootcamp itself. All of that is stored in GitHub, and it is all open. So what's happened over the years is that a number of other groups have started forking the entire instantiation of the bootcamp and made their own instance and started contributing and offering pull requests and things like that. So we're great users of GitHub. Okay, so let's go into object-oriented programming 2. I guess I can keep flipping through all this. That's the success baby, I guess. Right, so we talked about object-oriented programming in the context of animals and objects as animals because they had these things called attributes. That's basically data about those animals. There's sort of population things like related to all of the animals, all the bears in the population. So we really just showed and scratched the surface of how we create a class and how we instantiate an instance of a class. Now we're going to kill classes and do other fun things. Right, so as you saw with the init, the underscore init, this doesn't seem very loud. Are you guys able to hear me? And sound is good on the, okay. The mirror of underscore init, that is the method that gets called when you instantiate a new one of a class, is underscore del. And that's really considered the teardown. So this method gets called, you don't call it, or you don't have to call it explicitly, it gets called for you during sort of that garbage collection period. So let's see what that looks like. So if I create a class of a bear, and I say def underscore init, and I'm going to have one argument that I'll use when I create this bear, and I'm going to assign self.name equal to name, and I'll print during the instantiation process, made a bear called name. And then I'll also now create a new method, which is underscore del, and this takes no arguments. Bang, the name is basically no longer. So if I create two bears, one we'll call Yogi, another we'll call Cal, and we'll reference the instance of the first one with Y and the second one with C. What happens when I do that? Made a bear called Yogi, made a bear called Cal. Okay, we've already seen that before. Let me delete Y, and then I'll delete C out of my namespace, and in doing that, I'm basically calling the underscore del method, and we wind up killing off both of those bears. Now, what do you think happens when I go and actually execute this line? So I say Y equals bear Yogi, Y equals bear Cal. I'm creating an instance of a bear class, and I'm calling it Y. And then immediately thereafter, I wind up creating an instance of a bear class, and I assign it to Y, but Y's already been assigned. So Python says, I'll just get rid of the thing that you had me pointing to earlier, and now I'll basically point to this new thing. So it makes a Yogi, and then it calls Cal, right? And what did it do? Let's look at the order of this. First, I created Yogi, so that's just what we had before. So that was the left-hand side of the semicolon. And then it said, made a bear called Cal, because I created the instantiation. I instantiated a new bear class, right? And in doing so, that was what I did on the right-hand side of the colon. And then when I assigned that to Y, I had to delete Yogi. Is everyone clear on that? The ordering of that is pretty important.
Now, would that happen also if you put like Y equals 2?
If I said Y equals 2, all of that would be the same. That's correct. Except I wouldn't do the middle one. It wouldn't have made a bear called Cal. So F equals bear of name fuzzy. And if I exit out of Python, part of the garbage collection of Python is just to delete all out of the namespace and get rid of everything out of my namespace. And as I'm getting out of the Python interpreter, I wind up killing the bear. Yes? If I hadn't done what? If I Right, so if I hadn't written a del function, then there is a del function of a generic class, which is called object, that has a pass in it. It doesn't do anything. So when I exit out of Python, I'm actually calling the del class of all of my objects, but most of my objects, if you haven't been explicit about creating and what's called overloading the original del, will basically just get a pass. And I, of course, will wind up freeing up the memory, but that's something different than actually essentially shutting down an object. That's a good question. So importantly, init and del are not allowed to return anything, okay? And that's just required. These are special methods. And when you actually create a class, if you have a return statement inside of your init, Python will complain at you and essentially not effectively compile that class for you. So here's a slightly less trivial example of creating and destroying bears. Because as you see at the very top above this init, and this is a bear.py, and it's inside of the tarball, which you should already see on the website. So I have this bear_num, and that is an attribute of the bear class. And it's shared, that same attribute is shared amongst all the bears that I will wind up creating. Whenever I have a self, that is an attribute that's basically just associated with that instance. So let's see what this init does. Okay, so I have self.name equals name. So there I'm just assigning essentially a local variable. Name becomes an attribute of the instance. I'm going to print out that name. I'm going to open up a log file, and you notice I'm using the a tag. So that's saying append to this log file. I'm going to bump up the total number of bears in my population. So I do that with bear_num plus equals 1. I'm going to assign my number where I am in the population equal to that current number. And I'll wind up writing into that log file, and I'll flush out the log file. So I basically force the writing into that file. I'm not doing any sort of buffering at all. And I have a method that I've written called growl, and I have a method that I've written called __delete. Growl is something that I've created. I've just decided, remember, if you print out \n, that you'll get the sound from the terminal. So what does the del do? It basically looks at the name, it prints that out, it opens up the log file again, it flushes it out, and it decrements the total number of bears in the population. Okay, so let's do for bear import star. I will create a bear called Yogi. I will create another bear called Fuzzy. And what do you think the bear.bearnum is now? 2. Good. I will delete Yogi and I will delete Fuzzy. No longer, no longer. What is bearnum? 0. If I look at the log file that I actually created, which is pretty handy. Again, think of this in terms of the workflow that you might be creating for yourself. You're going to want to have log files. You're going to sort of keep track of what's been going on. Especially if you're running code that takes a long time, you want to be sort of snapshotting things at the file level. So at this time, I wound up creating a bear named Yogi and Fuzzy, and you see they got assigned the correct number that they were. And then I deleted the bear. And you notice that the population at the time that I deleted Yogi was actually 2, but Yogi knew what its when it was created, we saved that local version of which bear it was in the population, and then we also delete Fuzzy. Okay? Any questions about the del? And there's really that difference also about essentially local attributes, or we can call them private, but they're basically local attributes to individual instances, and that's what we had as .name. And then there's this thing called bearnum, which is essentially the total population, and that's kind of shared amongst all the other bears in the classes. So there are a bunch of special methods, as you probably can guess. A pretty important one that I use all the time is something called __str. And that's a method that defines how the class should represent itself as a string. We've seen this before. if you remember when you were playing around with the datetime module last time, you said, A equals datetime.datetime, and then you put in your birth date. And if you print out A, you wind up getting a pretty nice string representation of that. But that's just because somebody who is writing the datetime module actually wrote the __ string method. And what they realize is that probably when you print out something which is fairly complex, it's a complex object, you probably just want to see what the year is, what the day is, what the month is, and what the time is. Now, you can always rewrite this if you'd like to. So let's take a look at what this is. It must have self as an arg, and that's the only thing it can have, and it must return a string. You can do things inside of an __ str. That is, you can do a little calculation if you need to. You could even print, but typically you're just going to essentially create a string inside of this method, and you'll return that string when you're done. So here is a nice way of doing this in the context of a bear class. Name equals whatever the name is, what the bear number is, and what the current population is. So I made a bear called Fuzzy. Let me print B, right? And so I get name equals Fuzzy, bear equals 1, population equals 1. Let me create a bear named Yogi, and let me print B again. What do you think changes? Population is now 2. Okay, so this is very powerful, I think. And it's a way, as you saw before, of these sort of keeping these complex interactions in the ecosystem of these different objects. As I said, this is kind of what datetime did, and you've seen already this before. So there's another file in that same tarball called bear2.py. And what you see is that I've done a little bit of math inside of the __ string method. And there I'm actually calculating how old the bear is. And I'm doing that because upon instantiation, I actually saved a local attribute, which I'm going to call it created. And that's basically the date time as I've done this instantiation, so right now. So let me create Yogi again. I'll print A. And you see that I've now added this age. So this was, I basically did this 11 seconds later. And if I print A again, it's a little bit later, it's a little bit later, a little bit later, etc. Okay? So that's pretty useful, I think. And especially if you're building these complex objects as part of your workflow and you want to be sort of printing out the results of it, it's kind of a nice thing that an object knows how to represent itself. You shouldn't have to, outside of an object, figure out which attributes you actually want to surface and send back to the end user. So it turns out that, and in bear1.py, I've done a few of these, you can emulate numeric operators. And that is, you can teach these different objects how to handle themselves when I have like a plus sign, or when I have a division sign. What does it mean when Yogi is divided by Fuzzy? That doesn't make sense conceptually, but we might have some notion of what it means for Yogi and Fuzzy to be added together. And so we get to decide what it is that happens when these things happen. And so when you had a datetime object and you subtracted a datetime object, somebody who is working on this thought, oh, I should return back when I'm using the __ sub, which is the subtraction, I should return back a time delta object. And that makes sense. So we can define a whole bunch of ways that instances behave upon numerical operation. And what you see here is add, so __ add. And then what it takes now is an argument where I'm adding the other. So this would be a reference or a pointer to this other instance of the same class. So I'm going to create a cub, which will be of class bear. It'll be an instance of class bear. And I'm going to give it a name, which is the progeny of the self. So that is of the current bear, and then of the other bear, and the other bear's name. Okay, you see how I'm referencing that in the __ add? Likewise, I can create a multiplication, right? So here's my notion of when I add, I'm going to wind up creating a new cub, and I'm going to wind up returning a reference to that cub. and I'm going to set a new variable or a new attribute of that cub called parents. But in multiply, I basically have the same notion. So here, add and multiply basically have the same meaning to me. So if I multiply two bears together, it's the same thing as if I use the plus sign. And there, I can just call another method from within this class that I'm defining, and I'll just say, that's underscore underscore add. Okay? And you notice I'm leaving out the self here because whenever you call a method inside of a class, that first argument is basically inferred, and that's always considered to be self. All right, so let's actually see if this works. Y equals bear Yogi, C equals bear Fuzzy. I made a bear called Yogi and Fuzzy. And then we're going to return a kid from these two. They are going to procreate. Y plus C, we'll get a kid. I made a bear, a progeny of Yogi and Fuzzy. Our kid, if I hold down the tab, I wind up seeing all the things that are available to me, which is very nice. So I have a name, I have my name, I have bear num, I have parents. Okay? So our kid.parents, I get essentially a pointer to the instances, or basically this is just showing me where these guys are in memory of the two different bears that created this kid. But because this is just basically a list, or it's a tuple actually, I can look at the first one and look at its name, look at the second one, look at its name. Okay? What happens when I do rkid1 times? So we have instead of a plus, we have a times. Should get the same thing. Okay? There are a lot of these things you can do. Yes, there was a question in here.
So what would happen if you deleted one of the parent bears and you called the cub bear parents?
So the question is, if you deleted one of the cub bears and you tried to call from the back from the cub bear back to the parents. So it's interesting. This gets into what's called reference counting. And basically, you wind up removing all traces of an object and an instance of an object once nothing is pointing to it anymore. Okay? And so if I created Yogi and I said y equals bear Yogi, and I created then a kid, and I deleted y, I haven't actually deleted the data that's associated with Yogi. All I've done is I've removed a reference to this object. But if I have that reference that exists somewhere else in my existing namespace, then I haven't actually deleted that object, and I would still be able to go back and use .name. Okay, so when you're deleting a variable, you're effectively, and I know we say we didn't have to think much about memory, but we actually have to think a little bit about it now. You're effectively deleting a pointer to the data that lives in memory. Okay? Any other questions? Yes, there's a question up here.
About the add, when you named the cub, or like in the class,
Yeah.
you said what the cub was, and then parents looks like it's, I guess, an attribute of cub. So I guess it's confusing to me that that's not its own function, or like that cub isn't its own class.
Okay, so you're asking about this cub.parents line and what that actually means. So cub, what is cub? What is cub an instance of? Of a bear. I'm allowed to, after I create an instance, I can actually start overloading my instance with attributes that weren't there originally in the parent class. And so I could even create a whole new method if I really wanted to. This would be considered fairly bad coding practice as I put it here. What you'd probably want to do is in the init method of a bear class, you'd want to say cub.parents equals essentially, an empty tuple, right? And that means that I always know, even for the Adam and Eve of my whole bear population, it means that they basically aren't pointing back to their creators. Good question.
Yeah, on top of memory, so like every time you create an object, it's got these attributes tagged into it that, okay, I'm wondering, like, when you create a class called bear and you define this function called add that acts on bear, is that only stored in one place in memory, and then every time you create a new bear, you got a pointer to that one location in memory, or are there
Okay, so the question is, when I define a class, and then I define methods and attributes within that, and I create new instances of that class, am I basically creating large copies of not just the data associated with it, but also sort of the functionality throughout? And I believe the answer is that I'm more or less just creating compact representations of the data whenever I create all these different instances. And when I call a method, because the instance itself knows where in memory I basically have this whole notion of what a method is, like an init or a del, it goes off and it implements that functionality and applies it to the data that's local to me. We'll see a little bit more about kind of referencing in just a few slides. Okay, so __ dict, that's a dictionary containing all the class's namespace, so all the local stuff. __ doc, that's basically just the doc string of that object. _name, that's the name of the object. And there's a module, that's basically the module name where that class is defined. So basically this would be the name of the file if this was written inside of a script that you're executing. And bases, there is the notion of classes and subclasses, and this would be basically telling you what are the base classes, or basically what are the parent classes of the class that I've just created. This is obviously fairly rich. We're not going to have time to go into all of it, just show you a couple things. So if I print bear __ doc, that's basically the doc string. If I print name, it's just bear. If I print the module, it's __ main. Why do you think that is? Not because we imported into main, but close. It's because we ran this script essentially from the interpreter or from the command line. We didn't import this explicitly from somewhere else. Bases, there are no base classes of the bear class. Dict, these are all the things that it knows how to do. And so this is in some sense an answer to the question we just had. You notice that growl is a method, and you notice that growl it's considered a function, but we think of it as a method. It's the same thing basically. And that's actually just pointing to a place in memory. Yes, question?
Why is there no base class bear? I thought that the classes all descend from object.
Yeah, so that's a good question. The question was, why is there no a base class of bear? It's what I've actually done here is not considered great Python code. I didn't explicitly subclass the superclass of a thing called object. What you typically should do is when you're defining the bear class or any class, or you'd say class bear parentheses object. And that is how we actually wind up doing a subclass of a base class. And everything winds up deriving from this superclass called object. It turns out that if you don't put that object in there, you don't have access to some interesting things that Python can do with object-oriented programming. This was just sort of a shorthand for doing this. But you're absolutely right. This is actually a subclass of a base class called object. But it's not showing me that because I didn't explicitly say that. Good. Okay, we had a question earlier today about hiding class attributes and the notion between private and public. It's sort of, as I think the speaker made reference to, this was just sort of a design decision within Python. Let's actually try to hide a class data attribute. And we can have a super special attribute, which is __ secret count. And I'll do a count. And what I'll do each time I call this method, I will update this super secret count, and I will print out the super secret count, and I'll say counter equals just counter. What is the value of __ secret count right now after I've made this call? Is it 1? It's 0. Why is it 0? I don't have an init function here, right? I didn't call any init, and I haven't yet called count, so it's basically just set __ secret count equal to 0. So if I now do counter.count, I should get 1 and 2, right? Because I'm actually calling that method. And now all I want to do is I want to get access to that thing that is my super secret thing. and I get a trace back. Oh. So even though this is an attribute, and it's a legitimate attribute of the just counter class, I was able to hide it. And it turns out it's not actually hidden. If I really wanted to access it, I could, and I would access it with a object underscore class name underscore underscore super secret attribute. So if you have an attribute that starts with 2 underscores, and it's basically private, but if you really wanted to find it, you could find it. So that's an answer to your question up there. Yes.
Can you modify it?
I can modify it too, because now I know how to find it, and now I know the reference, what it's referencing. So now I can touch whatever it's referencing. Good. There's a question over there. That's a good question. This is one of the negatives of not doing this in IPython Notebook, because now let's try. All right, so class, test, object, and we're going to set secret equal to 0, and that should be enough. Now we'll say t equals test. T, let's see if this actually works. T underscore test underscore underscore secret. That's 0. Let me set that equal to 1. So it allowed me to do that. And I can actually change it. And now the question is, will it tab complete? So T underscore, it's not there, so let's, oh wait, no, it is there. Is that right? Yeah, it tab completes. Good question. Love it. All right, so here is sort of the most nitty-gritty slide of the entire bootcamp. So it's a little bit wonkish, so you have to bear with me. I'll try to be as didactic as possible. All right, so this is kind of where I said we didn't have to think much about memory. We kind of do. A equals bear yogi. All right, so what is A? That's just basically a pointer to some instance in memory. B equals A. So now I'm creating a new variable, and I'm pointing it to the same place that A is pointing to. So it references the same memory location. And you notice that I get the same value on the right-hand side there. And obviously, if you're doing this at home, you'll see a different number. That's not important. The point is that they should be the same. But you'll see a different number than what I have here up on the screen. OK, so let me set A.name of fuzzy. What do you think B.name is? Fuzzy. OK, because they're basically referencing the same part of data in memory. Bear.bearNum. How many times did I actually increment the bearNum counter? 1 time. So even though I now have what you might consider sort of 2 instances of bears, A and B are basically the same bear, but they're just getting pointed to by 2 different means, right? Or 2 different places. So I didn't actually call the underscore underscore init method of the bear class twice. I only called it once, and that's when I did that first line where I created yogi. I can do something called copy, and this is another method that's built in, and you can use this not just for objects, you can basically do it for a whole bunch of things. I'll make a copy of A, and I'll assign that to C. So now C is a new memory location. You notice it's a different value than I have somewhere else. What is bearNum? 1. And why is that?
Because copy doesn't call the bear function.
Exactly. Copy doesn't call it does not do a new instantiation of a bear class, right? It just takes a whole chunk of memory and just copies it over here, and it says, now you can point to that. Everyone get that? Okay, what's C.name? It's fuzzy, right? Because I just copied all that stuff over. So I had that before. Now let me set C's name to smelly. And what's A's name now? It's still fuzzy. Right? It's still fuzzy because C is a different copy altogether in memory, and A, I haven't touched its name yet. Let me overload a new attribute on A, and I'm going to create a list. 1, 2, 3. What is C.mylist? Isn't C a copy of A? No, I copied it before. I got to trace back. Doesn't know what that is yet because I played around with memory over here, but I've already made that copy over there. So let me make another copy of A. And what is D's mylist? It's there, right? Okay, what is D's name? Fuzzy, good. And then we set D's name to be Yogi. What's A's name now? Fuzzy. Why is that? Because D is a copy in a different place in memory, and A is pointing to a different chunk of memory. Let me set my list to 0, the 0th element to -1 of A. What is it for D? We hear 1, 2, 3. Oh, no, it's not. This is horrible. We had it all worked out. We were making copies of memory, and now I played around with a list over here, and over here I also wound up getting the same thing that happened over there. What's an argument for that?
So does A only store the pointer mylist?
So the hypothesis is that A only stores the pointer to my list. It isn't actually storing the data associated with that. But that's sort of counter to what I saw before, where I was changing the name of D and changing the name of A, and those were essentially independent of each other. Why are they now coupled together? Well, I changed, that's true. Well, they are talking to each other. I could have done, it's symmetric.
When you write A.name equals, you're changing what the name pointer points to. No.
If I changed A.name, that would not change D. And the reason...
So like, I think you changed what the name pointer points to.
Almost.
I'm going to learn a lot if this is wrong.
Okay, almost.
Similar to C, I mean, lists and dictionaries are stored as an address. So, and they point to an address. It doesn't need to be within that copy of that.
That's exactly right. So just for those that didn't hear that, when we have lists and dictionaries, these are mutable objects, right? We can change them. And when they're mutable, Python, instead of just trying to map out a piece of memory and says, okay, you can have that. If I say y equals 5, that's just assigning a variable y equal to 5. And if I set y equal to some dictionary, the difference here is that y in the second context is actually pointing to something, whereas in the first context where y equals 5, I assign a value of 5. And while all this is happening in memory, the way to think about it is that if you have a mutable object, like a dictionary, like a list, or like an object itself, all you do when you make a copy is you make a copy of the reference to that thing. So when I created a.mylist at the very top on the right, what I did is I created a new chunk of memory that was nowhere near in physical memory space where all these bears lived and all the instance data lived. All I did was I created a little pointer back to that place over there. And when I made the copy to D, I copied the pointer. So now D and A are both pointing to the same list. And if I change that list, then indeed I wind up getting, I wind up sort of sharing that change. So Python knows this is an issue, and they let you do something called deep copy. And so what this does is it basically walks down the reference tree, and every time it finds a pointer, it goes to that place in memory, and it makes a full copy of that. And if inside this list I had another list, I would have another pointer somewhere else. okay? And it would just keep on walking down and just keep on copying memory. So if you want to make a copy and you have a complex object, don't use copy, use deep copy. All of that just to say that. Okay, so I just made a deep copy of A. And A is my list. Now the first element I set to the letter A. What is E my list? Minus 1, 2, 3. Okay? Yes, question? The question is, if I ask for the location of my list in memory, would it tell me what I'm doing wrong? How would it know that I'm doing something wrong?
No, I mean, where you're making the copy before you did deep copy,
Yep.
you ask the location of a.mylist and b.mylist.
Yep.
Would they be pointing to the same place as they, that was sort of...
Yeah, again, I should have done this in the notebook, so I will do it in the notebook. Let's try that, okay? So I'll set, I've got this thing T, right? And that's some location in memory. Let me say T my list is equal to 1, 2, 3. Okay? And let me import copy. And then I'll say C equals copy.copy of T. Okay, so now let me look at C. Is indeed, whoops, look at T as well. I think I can use ID. No, that's not right. Let me try this. Yeah, okay, so they're at different locations. So ID is saying something else. Let's take a look at my list, okay? So T dot my list. And does anyone remember how I get the address location of a list? I would have thought ID, but that wasn't right.
There's a .x.
I don't think so. Can I have some help from a counselor, please? No? Okay. Let me, I'm trying to figure out how to get the memory location of my list.
What was the matter with ID? They were different when you did it with C and T.
Oh, was it different? I thought it was the same, and then I got confused. All right, let's try this. Okay, so those are the same. And let's try now deep copy. So indeed, C is in a different place. So T my list, and it is indeed different. Thank you. You can be a counselor next year. So does everyone get that? So I did a deep copy, and I basically made a whole new place in memory for the second my list.
So Josh, it is ID. It's just numerically listed. So if you put that into hex, you hex around that, and that'll be the memory.
The point is these numbers are different. Yeah. And I guess when I was printing out C and T, when I was making just a copy, I was confused that it looked to me like they were the same, but they must not have been the same.
So if you put, I'm just saying, if you put hex in front of, in 20, if you put hex around that, it'll be identical to the thing that got printed.
Well, you got recopy.
Oh, I did a recopy.
Then you got to rerun.
Yeah, rerun 19 and those numbers will match.
No, they don't.
Yeah, I think they're not supposed to. It seems like a different thing.
Yeah, I believe that ID is related to the location of memory, and this may oh, because it's I list. Yeah. Sorry. Yeah. Okay. Let's see if that's right. Aha. Yes. Mind not blown. Mind blown by not being blown recursively. Sorry. It's on the web now. That's a tweetable moment. All right, so we're going to do subclassing and inheritance. Everyone okay with that? I think we were really good up until that last moment, but even in that last moment, if you look back at the videotape, you realize that we actually said everything right. We just said it in a long-winded way. But I want you all to understand and be comfortable with the fact that when you have these complex objects, if you only take away one thing, it's if you're copying these things, make deep copies of them, please. And when you make copies of things, you're not actually doing any instantiation of a new object. Yes, you've got a new one out there in memory, and you probably never want to do that if you're trying to keep track of a bear population. That's not how you would make a copy. You would maybe make an instance of essentially an empty bear, and then go through and copy over the names. Or make your copy and then call the init function of that same bear so that you bump up the population number. Was there a question up there?
Yeah. So the big thing is that only for immutable objects you make actual copies, but for mutable objects you point to the location.
For mutable objects, you're creating pointers to them. For immutable objects, you're just creating actual, copies of the data.
And that's strings and numbers and complex.
That's strings, numbers, complex numbers, tuples. Of course, inside of tuples, I could have lists, and those, then what the tuple is just basically I'm making direct copies of all the pointers to all those lists. Okay. A bit on subclassing and inheritance. The base class of the current class that I'm creating is called this way. And so, for instance, if I'm creating the notion of a flower, that is a obvious subclass of a base class called a plant. So here we would say the class flower is a subclass of the base class plant. The plant itself may be a subclass of living thing. And I had one more thing to say there. Attributes of the base class are what's called inherited by the subclass. So if I create an underscore string method for the plant class, and I don't actually create an underscore string method for the flower class, then whenever I print out an instance of type flower, I will basically use the string method of the plant. So let's see how this looks. So here's a class plant, and the number of those known is 0. We'll set the lat name, the common name, and we'll bump up the total number of plants known. Not all plants have petals, but let's say all flowers do, just for simplicity. And we'll now make a new class, which is a subclass of the base class plant, and we'll call that flower, and that will have one attribute, which is has petals. So now let me actually try to do this. P equals plant, poison, ivy. E equals flower, poppy. E has petals. True. Plant.num known. How many times did I call the init class? I called it twice. And you notice when I created E and I basically made a flower, there's no init inside of flower. And so if there is no init inside of flower, I'm going to call the parent class or the base class. I'm going to call its method. So instantiation of a flower reuses the init from the plant class. It also sets petals equal to true. So if I go into flower and I look at this thing called underscore bases and I look at its name, this is now telling me all the base classes of my current class, and that's plant. So I can know if I'm basically inside of a class what the parent classes are. So here we are, we're creating a string method. So I'm a plant, I'm a flower inside of the plant and inside the flower respectively. Now the underscore str method of flower takes precedence over the underscore str method of a parent class. So if you make basically one of these methods and your parent class has that already predefined, you're basically overwriting it. Or at least you're not going to memory and chunking it up. you're basically not using it. You're using yours preferentially. So f equals flower rose, print f, I'm a flower. P equals plant oak, I'm a plant of oak. So that actually works. Sometimes we actually want to do what the parent class was doing or the base class was doing and use its init function. But now we want to add some other stuff. So here's what we might do inside of the flower. So we would have our own init. So we'd be called in our own special ways. And then we would first call the plant's init method and use all the things that we need to on the plant side, but now kind of overload with special attributes that only make sense in the context of flower. So f equals flower rose, print f, I'm a flower, f.end petals is 5. Any questions about that? Yes, up there.
So if you're initializing, how do the two init functions interact? Like you init those variables first, and then you init the plant variables. Now you have like all of those variables together. Like, do they add together?
Yeah, so the question is, what's the interaction between the two inits of plant and flower? Well, remember, if I just wrote my own init function method inside of flower, and I didn't use anything from plant, I would overload, I would basically ignore whatever plant's doing in its init. But I really like that in plant, I'm actually setting the common name and the Latin name, for instance, right? So I want to use whatever it's doing, and it's also bumping up the total number of plants known. I don't want to have to deal with whatever the parent knows what to do or how to do it. But I do know there's some things that I want to do special for myself. So the only way that I have that interaction is when I explicitly create it in the first line of my own init inside a flower, where I actually explicitly call the plant's init method. And you notice that I can call it because it's just a method, and I have access to it, right? There's nothing private about the underscore init of any class. So they're only interacting because I've explicitly asked it to in my subclass. You can do multiple inheritances, and it gets obviously pretty interesting in terms of your capability of building up a large ecosystem of different classes. So here's a new class, flower 1. It's a subclass of plant, edible food, and smelly stuff. So I might have inits in a smelly stuff class and an edible food class and in a plant class. It's pretty obvious that all these things are sort of subsets of each other. And so I won't go into the details of this, but there is an explicit ordering of which, one of the classes you wind up using and the methods inside of those classes based on the ordering that you subclass those base classes. Remember from before, earlier today, we talked about error handling. We had try, except, finally. The except line right there is essentially catching all the errors that I might wind up getting inside of the try block. And those errors could be a keyboard error, so I could do a Control-C, and that sort of sends a keyboard interrupt. I could do a math error, so I could have like a divide by 0 error somewhere. If I'm trying to read in a file, inside of my try block and that file doesn't exist, I'll get some file IO error. Each one of those errors are thrown by the underscoring interpreter when something goes wrong, kind of in the context that that error is known for. And all of exceptions that are in Python are basically part of a very large hierarchy of objects and classes. So you see a whole bunch of those listed on the left-hand side right there, a whole bunch of different errors. When I divide pi by 0, I get a 0 division error, right? And you can imagine that that is a subclass of a larger sort of math error class. And we can handle these errors explicitly now by catching them and doing something different with them. So here's something that fails. I'll set x equal to a number that blows up. Inside of my function, I'll try this thing which is going to fail. If I have a 0 division error, I'm going to save that error as something called detail, and I'll print out what those details are of the error. And here, I wind up sort of gracefully, instead of bailing out and essentially stopping the execution of my program, I wind up now basically just giving something nice back to the user. And if this is not absolutely critical that that try block had to work, maybe I'll just wind up going on and doing my computation. So to make your own exceptions, you can import the exceptions module and go to town. Yes?
How does the try substatement work differently with warnings? Because those, in that case, the try statement could have worked to some extent.
So there's a question about warnings, and there is kind of a whole warning mechanism within Python. Warnings, I believe, are just part of the exception class. And when, basically you set the level of warning that you're willing to tolerate when you're running a script, what you're basically doing is you're telling the interpreter, don't, consider this an except, essentially throw this as an exception, but it's not that bad, so keep going. We didn't really get into warnings in the boot camp, but it's obviously very useful to set different levels. That's effectively hitting some threshold where if you say this is a critical error, then throw a critical error exception, catch it, and do something with it. Typically, if you have a program that's throwing warnings and throwing errors, it'll be sort of pretty sophisticatedly architected around doing exceptions well based on all these different levels. And there's actually ways to do it. I think it's import warnings, right? And then you can get access to that more easily. Just a couple more things here. So if I divide x and y, if I get a zero division error, maybe I want to catch that and print that. Or I can print the result. And we try 2 divided by 1. That's OK. 2 divided by 0. Oh, division by 0. What's 2 divided by 1 where they're both strings? I'm catching the exceptions, right? No. I didn't catch the exception, which is a, can't do that because you're trying to divide strings. But I did execute the finally clause. So if I want to catch, say, whatever the error is when you divide these two things, let's see what that looks like. Chris, how am I doing on time?
It's 3:31.
I know that, but how am I doing?
We're supposed to end at
3:25? Okay, so I will yield the balance of my negative 6 minutes to myself. So let's see what kind of error I wind up getting here. So I got a type error. So if I wanted to catch that error in that code block, I would just put in a except type error over here. Okay? And then maybe I would do something with it. Here's an example of where we catch multiple errors, and it's sometimes handy. I won't go through all this, but just to show you, it's sometimes handy to catch this and print out some of the detailed results. Oftentimes, I'll use this sys.exe_info, which is pretty useful to essentially print back the stack trace of what went wrong. But this is a very volatile code that will execute no matter what, right? Because if I don't catch the IO error and I don't catch a value error, and it's an error I never even thought of before when I was writing my code, I will catch it, and I will not crash out of my code. This is that black box thing with the airplane. But I can raise some exception just if I want to that'll allow me to basically pause the execution. We can create our own, we basically can raise a name error if we really want to. And I think there was a question earlier today about throwing errors in the context of Java. That's essentially what this is doing here. So here's kind of a text version of the hierarchy of all these different classes. They are all subclasses of the base exception. And you see that keyboard interrupt is its own special class. But then there's all these things which are basically called exceptions, and you see how they're all kind of laid out together. I won't go into making our own exceptions, but it's in the notes, so you should be able to see that in the PDF. And I think that's it. Just to give you a sense of what we're going to do now, we have no breakout, because your mind would be blown if you had to do a breakout on this stuff. But I do encourage you to go through making your own exception classes. We're going to do a bit of plotting And then what we'll do is we'll end with about 5 minutes to stretch your legs. And then we're going to have this industry panel, which will start at 4:30. And we'll basically talk about Python in industry and also academia. Some of the people here come from academia on the panel. Then at 5:30, we'll go upstairs. And upstairs, there'll be a nice sort of social event for all of us to gather and let off a little steam. All right, so I'll end here, hand it over to Chris.
Thank you.
Gotta use the screws, yo. This is low resolution. Okay, so before I begin, I just want to first plug a couple of, I guess, ongoing seminars that are going to be starting this semester for Python on campus. The first is Python for Data Analysis, and the second one is Python and Text. And these are basically, I think, people who get together. It's somewhat coordinated, and they discuss the problems that they are trying to solve, and they talk about tutorials that they're going through. And it's kind of like a class, but not as serious. And it's run through this DLab collaboratory. And I think Fernando will post links to these on the HipChat channel, so you can find out more about them. They're pretty informative for ongoing. If you don't want to get as invested as to take the 250 class, and if you are particularly looking for help with tutorials on data analysis with Python or managing text with Python. Okay, so if you went and you downloaded the archive, you found the Matplotlib tutorial IPython notebook. So let me start that up in slideshow mode. Let's see. And we can do this. Not too bad. Okay. And yes. So let me quit HipChat so we don't get hit every time somebody asks something. So plotting with Matplotlib is not the easiest thing in the world, in part, in my opinion, because the system that it's designed around is a little bit evolved and kludgy. It's not like it was designed from the ground up following one set system. So there is a system which is better than nothing, but a lot of learning how to use Matplotlib, the more advanced features, is going to be a lot trial and error. Here is the outline for the tutorial. First, I will talk about the two application programming interfaces, APIs for Matplotlib, and those are PyPlot and then the conventional object-oriented approach. And I'll show you simple plots comparing both methods so you can see exactly how, for example, if you want to plot a line, it looks with PyPlot versus using the axis objects and calling plot on those objects. And then one of the important things for making plots for scientific literature is plots within larger frames, and those are called subplots. And we'll go over how to create subplots both interactively and all at once, and then how to do them in a nice grid layout with different column and row spans. And it's not too hard, but it does follow its own system. And then after that, I'll go over axis sharing, how you can have different subplots share the x or y axes or both, so that they are aligned with the same limits and the same tick marks and everything. And then after all that, I'll get into how you can customize how your plots look. And you'll see that if you are running your IPython notebook from within the zip archive that was posted on the website, that is preferable for this talk, because I have bundled in there a file which will set the default plotting parameters for when you execute within that directory. And then we'll talk a little bit more about the returned line, axis, and figure objects, which will help inform how you can use explicit object-oriented calls to perform your plotting. And basically, I'll break down what a very common plot looks like using this OO technique. And then I'll go over all the popular various types of plots that you'll see in scientific literature and for anything, starting with error bars and ending with contour plots. And then how to place text and do LaTeX formatting in Matplotlib. And then if there's time, or if you're super interested and you ask me about it later or read the notebook later, I'll show you how to do basic event handling, which allows you to interact with plots that have been popped out into Windows. So you can click somewhere, get data from that user's interaction, or you can move a slider and change the frequency that you're folding the data on. And it's basically very powerful interactive hooks that can be easily developed in Matplotlib using Python to help you explore your data quickly. And then also I'll show you how to read in and display images and very basic rudimentary simple 3D plotting. Okay, so as I said, there are two main APIs, the PyPlot interaction level and the object-oriented way. And PyPlot is basically the high-level MATLAB-like library that automatically manages details like figure creation. And on the other hand, the internal object-oriented structure gives you much more control over what you're plotting and the plot elements at the expense of slightly more verbose calls, and you have to be more familiar with what you're doing, or you're going to get a lot of errors because of unrecognized requests. So the PyPlot API is easy to use, and it's generally sufficient for pretty basic simple plotting. And as I said, it doesn't offer complete control over details. So here is how you would execute it. Before we do anything, we have to say pylab inline, which many of you learned in the homework from last night. So here is a very simple PyPlot call for plot. We're just going to define some data, x and y, which is just a sign of the x data, and then plot it up. It's just, so when you do the magic function on the last page, this magic, oh no, too far. Yeah. When we called %sign pylab, we imported a bunch of libraries, well, two main libraries. We imported, this is essentially shorthand for import numpy as np and import matplotlib .pyplot as plt. So everything that we want to use pyplot, we can just do plt dot, so plt dot xy, and then we'll label it. And the label allows us to put that label in the legend, and then we'll just slap a title on there and x and y labels. And if you follow along and execute it with me, you've now created a sine wave plot. And so there is the legend in the default position. It has a little bit of smart internals in placing the legend, but oftentimes you're going to want to override that, and I'll show you how to do that as we go on. Okay, so here's how you would make that same plot with the object-oriented calls. So first, we'll create a figure and an axis, and we do that with plot.subplots. And then we plot onto the axis object the x and the y data. We put that legend onto the axis object, and likewise, we set a title, we set an x label, and we set a y label. When you execute it, you get graphically an identical plot. I just want to mention these two exposed but oftentimes used internally matplotlib functions. They are getCurrentFigure and getCurrentAccess. If you start plotting with PyPlot and you want to go back and start accessing the axis and figure elements that were created that you're currently looking at, you can use these calls to return those. Okay, so making subplots. In the most recent code block, I showed you how to create a figure and an axis using plot.subplots. and you can create them independently with f equals plot.figure and axis equals f, once you have a figure, dot add subplot 111. And this 111 there is basically telling it where to put it and how big you want your grid of subplots to be. But I'll show you an easier way to do that in the next section. Okay, so here we can create a regular plot grid, and we can align them to be horizontally or just sit by itself, so simple plot and then aligned subplots. We did that by saying that we want 2 of them to be aligned, to be horizontally aligned. And then if we comment out this line and then comment out the next one, there we go, we will make them vertically aligned in that second plot that we make. Yeah? Okay? So it's not too complicated. It's just plot.subplots, and then you give it the parameters 2 and 1 to get vertically stacked and 1 and 2 to get horizontally. And this fig size is just to make it so it's big here on the screen.
How many figures were in that? 2?
So there were 2 figures. I just made the simple one first to just show you how you could do subplots without putting any of those numbers of rows or columns in there. And this one was a second figure. I just overwrote the F. And the inline backend for Matplotlib just spits it out here as soon as it makes it. Well, it basically, it draws it here and then fills it in. And then when you make a new figure, it draws another figure below it in the notebook and then fills it in as you plot things on the axes of that figure. Oh, so that's to show that we're unpacking. Oh, I'm sorry. So the question was, what's going on with this F comma here? Why do we need to put the comma? And we're unpacking the return from the call plt.subplots. So plt.subplots returns basically a iterable object where the first thing is the figure and the next thing is another iterable object of axis elements. So the first thing in that is the figure, and then the second thing is the axes, and in that second thing there's 2 things, each of which is its own axis. So it's just dynamically unpacking, just to make it shorter here in the code block. Okay, so if we want to be more awesome than just using that subplots, we can do subplot to grid, which I think is a much easier way to kind of visualize how you're going to space your subplots when you want to create your figure. So first make the figure, and then onto the figure you can create subplots with plot.subplot to grid. And here the first tuple is the shape, so we're making a 3 by 3 large grid of subplots. The second tuple is the location of that axis which is being created. So axis 1 is going to be created at location 0, 0, and then you can optionally give it row spans or column spans. And if you don't give it any, it assumes it's 1. But here we're going to make axis 1 span 3 columns, axis 2 span 2 columns, axis 3 span 2 rows, and then the rest just 1 by 1s. And then below that, this is just to turn off the tick marks to make it easier to see. And then we'll put a super title on the top. And here we have it. So you've got a 3-column axis 1, a 2-column axis 2, a 2-row axis 3, and then 4 and 5 are just 1 by 1. And a note here, this is how you make titles above all of your subplots on one figure. Each of the axes can have their own set title command, and I'll show you that later, but this subtitle, this super title, is how you create a figure level title. And you can change font size like this, and we'll talk about that a little bit more as well. Okay. So once you've got all these subplots and you want to have your data kind of share the same axis range, how do you force the subplots to align with those axes? Here we're going to create just X and Y data. It doesn't matter too much what it is, but I'll be changing it to show how it adaptively changes the subplot X and Y limits. And here we are. This is sharing on the x-axis. And we asked the subplots to share on the x-axis by when we created the subplots with this subplots command, we told it share x. It's that simple. Share x equals true. And now you'll notice that from 0 to 7, it is shared. Now normally, it would have made the second subplot, it would have shrunk the x and y limits to start where the data starts. But it's got to start where the data on the top subplot starts because it's sharing the x value axis. So if we turn this false, let's see what happens. It just chose to do it anyways. X plus, let's make it ridiculous. Yeah, so now you see when I shifted the x data for here farther to the right, the axis of the second subplot shifts with it, and they're no longer shared. However, if we turn sharing back on, there we go. It's now forced to share the same axis even though it distorts the data a little bit in filling up the subplots. Okay, and that same syntax is true for sharing y. So here it is, shared y data. Instead of on the right-hand axis, the plot limits being shrunken down to fit around the data in y in the vertical space. It's expanded to match the y-axis limits on the left-hand subplot. And you can also share both. So here we forced everything to go from the same limits in y and the same limits in x, regardless of how Matplotlib would have adaptively changed your x and y limits to fit the data. Okay, so not too hard. Yeah.
How did you get the gap between the plots?
Okay, so the question is, how do you make the gaps go away? And that, I believe, is noted here. Subplots underscore adjust, h space equals 0. So that's saying I don't want any horizontal space. And you can change this if you have like weird x or y labels that are multiple lines. You can make this bigger to allow your subplots to have not overrunning with the x and y labels. And w space is for width space. Yeah, thank you. Okay, so how you customize a plot's appearance. So very basically, this will make a very basic line plot, but I can give it a line style and a color. And I just do it under the plot call by giving a line style and a color. Okay, so not too hard. And this is basically how you would change things for any plotting elements. You can change it when you create that element. And I'll show you later, shortly, how you change it afterwards. You can recover using the object-oriented interface, and I'll talk much more about this when we talk about lines, figures, and axes. You can, when you make this plot call, save the line figure and then mess with that line figure even after the plot has been drawn. So once you save that line figure and you want to know what you can change about it, in the interactive IPython interpreter, you can just do line.set and then tab complete it, and it'll show you a huge list of everything that can be changed about lines. You can change the color, you can change the marker size, you can change the marker and the line style. Those are very common ones. You can change the alpha, which is the transparency. And any object that gets returned generally has set underscore attributes that you can change after the fact and also change when you created that element. And you should explore them because, as I've said, there is a system, but it's not always consistent in Matplotlib. Okay, so here we are. We're going to do this again so that we can save it in our notebook. So there's the line, and the default with our set defaults is blue, solid line, width of 1. And we can use the setP command, which is short for set property, to do a couple of things. First, excuse me, we can use it to learn about a specific attribute for a given element. So given this line that I just created, we can call setP line and then something we know exists, but we want to know what the options are for that attribute. And here we see that the options for line style are well, they're coded, but this is solid, dashed, dash dotted, double dotted, etc. And then if you just call setp on line, you get the huge list of everything that you can set, and you'll see that line style is one of the things that are listed here, as well as things like line width or marker size, stuff and all that. So you can see everything by using setp. Okay, and this is basically just summarizing what I just said. And the second primary use of setp is to change the attributes of objects after you've created them. So here, let me comment out this guy and run it. And we're just going to create a simple line plot. And we see that we got one blue and one green. But now, if I uncomment the setp call, and I want to change all the line widths at once and all the colors to red, I can do that all at once. And now, if we had paused and looked here, we would have seen that it used to be green and blue, but then we overrode it with red and line width 2. So if you create a big plot and you want to change all of the axis elements at once, you can give them all to setp. Well, not all of the figure drawn elements that are of the same type, and you want to change them all at once, you can do it very easily with setp. Okay, so, and of course you can also just use set. So line.set is another way of easily doing this on a single element instead of going through setp. And this will just do it as well. So here we've changed the line to be green with this dash dot. All right, so now I've been talking a lot about all these attributes, and Matplotlib comes with basically a configuration file which sets the defaults for all of these attributes. And if you've been noticed, the plots that I'm making are a little bit tweaked compared to the normal plots that you would see from the default configuration file with Matplotlib. And that's because I've changed it, and I've also changed the one in the zip archive. Okay, so this file can live in 3 different locations, and it's kind of like a hierarchy. The global installation for you guys is going to be under your username, so user's username, Anaconda, etc., down to Matplotlib RC. And this is the one that it uses when it doesn't find any other configuration file. If you make one under your username .matplotlib directory and put a matplotlib RC file in there, then that one will supersede the installation-wide release for whenever that user makes a plot with Python. And then finally, the way that we're doing it is I've put a matplotlib RC file in the same directory as the IPython notebook, so it's dictating to Matplotlib what all those defaults should be. The main ones I've changed is the fonts to be Times New Roman because I like it, and the font sizes so that it's more readable, and also the figure size and some of the tick mark sizing. But I won't go through this now. You can open up the file and read all the comments because it's very well documented what each line in there does and how it changes the different plotting element attributes. Okay. Yeah. And there's a customization tutorial that I linked to here, so you can learn more about that Matplotlib RC file and the RC params, which you can set dynamically in your code as you're plotting. So if you only want to change it for that script, you can change it right there, instead of changing the local configuration file. All right, so now we're going to dig more into the object-oriented approach by learning what objects are returned and how they work. So lines are one of the basic elements, and in a simple plot, this returns for us a list of lines. And so here in the notebook in IPython, when you call something, it tries to show you what you've just created in that last line. So here it is. The output is a line stored at this location in memory. All right, so we can capture that. And then, as I've shown above, we can set things with that object. So now that we've captured it into line, we can use line and change line and access the methods under that object. If you hadn't bothered to capture it, you wouldn't be able to do it. And one that I want to point out for line is set data. So what do you think set data might do? Well, it's pretty cool because you can create a line plot it and decide later that you actually didn't like the data you plotted that line from, so just change the data, don't change anything else about the plot. So here we're going to do that. First, we create this really basic line, goes 1, 2, 3, and then we'll make the plot. But then later on, let's say, oh man, I really wanted to use data x and y, and it's going to be a quadratic. So we'll put x and y using set data into line. However, what's going to happen if you comment out the rest of this? Here. Is you're going to get the plot, but it's going to look, you're not going to see the data because even though somewhere in this, well, in Matplotlib's figure somewhere, that line exists, but it doesn't exist on the x and y axes of this plot because Matplotlib drew the limits for the x and y axes based on the simple 1, 2, 3 data. Now, going back and reinstating these lines serve the purpose of recalculating the x and y limits. And so now we see that the x and y limits have changed to actually show the data in the line after we've reset the data. Okay? So up in this first plot call, Matplotlib made the figure and gave it x and y limits. Then we changed the data and we had to recalculate the x and y limits by first grabbing the access object, calling relimit, and then autoscale view, and then redrawing the plot to actually cause the notebook to re-show us the new plot. Okay? So that's kind of powerful if you're prototyping something in an interactive environment and then later on decide to replot that same single element but with new data. Over here?
Can you replot dynamically, or do you have to wait until the script is complete?
So you won't see it. The question is, can you replot dynamically or do you have to wait for the script to complete? So if you do this in a script, as I kind of did the second time I ran this through, you don't see the first plot with the original boring data in it because, well, the figure is not displayed to you until the code block is completed. So if you do it interactively in an IPython terminal, kind of like when I commented out the bottom of this code block, you'll see it, and then you call set data, and it'll change the line, and then you can recall, as long as you call draw, and then you can do the recalculation of the scaling, and you'll see it change as well after you call draw again. Over here? Lines followed by, the question is, why is line followed by a comma up here in the first line? And that's because you're unpacking a list of lines. So you would have gotten a list of lines, but we only care about the first element in that list. So that's why. Okay, so above lines, there are axes. And axes are pretty much as important as lines because they contain as methods most of the Matplotlib functionality for drawing plots. And one of the basic things is that .plot is called directly on an axis object. So, and you can see it all by first creating a figure and then creating an axis off that figure, and then axis dot tab completing. You'll see that there are 299 different methods built under axis. And this I just said, so here we go. Okay. And then the final object I'll be talking about is the figure. The figure contains all the axes and all the lines within it. So here in this non-interactive code, I'm showing first we create a figure, and then we'll add a subplot. So the return of figure is not really anything important, but the return of add subplot is an axis element at this location in memory. And then if we call f.axes, it exposes to us all the axes that are within the figure f. And then we can add another subplot to the figure f, and now when we call f.axes again, we get that list of axes elements, but now there's two of them because we've added another one to it. Okay? So that's just showing how the objects of figures are built up as you add more subplots. You add more axes. And you can learn more about this in the artist tutorial. But there are other things like patches in addition to lines, but they are beyond the scope of this introduction. Okay, so here I'm going to break down for you a common plot. Ooh, it looks pretty big on this resolution. Once you get the hang of it, it's not that bad. So first, create a figure and an axis, pretty simple. Create some data, and then we'll drop the data in. So this data is just going to be 3 polynomials, a linear, a quadratic, and a cubic. The linear, I'll use the defaults to plot it as a line. The quadratic, I will use a dashed line style. And the cubic, I will set a marker as a circle, a marker size of 10, and an alpha of 0.7 to let you kind of see through it transparently a little bit. And then, after all that is done, and to refresh you on set P, I'll use set P to change all the lines under axis, under the axis object AX, to have a line width of 2. I'll throw a grid on there because it's attractive. I'll put a fancy boxed legend in the lower right corner with some padding and some appropriately chosen handle and label spacing. And then I'll drop a horizontal line and a vertical line at the origin in black, and a title and some axis labels. And there we are. So you see the fanciness of the legend, and you can see, if you kind of look closely, the transparency in the red cubic line. And if this is all you need to do, it is that simple. But you probably need to do more. So if you are a good scientist, you have error bars, and you want to plot them, and this is how you do it. It's just, instead of plot, you call error bar, and in addition to your x and your y data, you can give it iterables of x and y error bar lengths. And here I'm just creating some data, and I'm giving it some jitter, just to throw in some jitter using np.random so that it's not a perfect line. And I'll throw in randomly generated error bars to show that they can be different lengths. And there it is. And of course, every time I plot this, you'll get slightly different error bars. But here you see that each data point has its own error bar, which is great because oftentimes your data has independent errors. All right. We can take this a little step further by showing that you can have symmetric error bars in the x-axis, symmetric in the y-axis, that's vertically symmetric, horizontally symmetric, or you can have asymmetric x and y axes. And the way you do this is just in the error bar call. You can have vertically symmetric by only giving it vertical, axis symmetric by only giving it horizontally symmetric by only giving it x errors. Or if you wanted to be asymmetric, you can give it a list of 2 iterables, each of length, your total length of your x and y data, where each one of these can be different, so that no longer is the left-hand side and the right-hand side of your error bar the same. Each half of your error bar can be a different length. And here we have it. So vertically symmetric, horizontally symmetric, and then horizontally and vertically asymmetric. You see that, for example, here, the left error bar is shorter than the right error bar, and the bottoms are shorter than the tops. And then you can have missymmetry, where in this case, the x is symmetric and the y is asymmetric. And I've also just made it different colors just to show that you can. Okay, so let's talk about some log plots. And here, let me drop the figure. So the one on the left is a linear plot. The one in the middle is a semi-log y plot. And the one on the right is a log-log plot. So you'll see, to make a semi-log y, it's just, instead of calling plot, you call semi-log y. And you give it the same stuff, and it makes it look like this. And then to do log-log, it's just log-log, x and y data. One thing to note about using log plots in the way that I'm showing you right here is that you don't go to 0, right? Because you can't go to 0 on a logarithmic scale. And obviously, you can't go negative. And so in the y-axis here, there's no 0 data. And here in the log-log, the x data, which was negative, simply is not shown in this plot on the right. OK. But then you're like, oh, but I really want to show negative values. OK. Well, you can use symlog. And symlog is called as a x scale or a y scale, which you set on your axis element. So once we create the plot of x and y just using plot, you do axis1.setXscale symlog, or symlog x, if you want to do it for the symlog x. And then I also show you symlog y. And then I'll also show you with both. So here we go. And what this does is it creates a linear range near 0 and then symmetrizes the negative using the positive data. So you can see in the top plot here, it looks linear around x values near 0, and then when x is negative, it is symmetric with where it is positive. And here, this is semilog y, so near the 0 in the vertical axis, it is linear, and then symmetric when negative, and here is semilog in both axes. So it is linear near 0 on both x and y here, and then it goes logarithmic, and then symmetric in the negative regions. Okay. So I should have about 10 minutes, so we gotta go faster. Bar plots. I don't like bar plots, but here's a pretty one. Basically, you drop rectangles, and you gotta, well, I don't like it in part because it's not a very good way of showing data, but also because you have to specify, if you want it to make pretty, you have to specify widths for each of the bars to show where they're dropping, and if you want to do multiple groups who have men and women, you have to add on to the locations by the width, basically, for each subsequent group. I'll let you go back and read that later if you really care about bar plots. Scatter plots, much more important, in my opinion, because I do a lot of scatter plotting. And you might say, well, isn't a scatter plot just a line plot with a line style of none and with using markers? Well, that's true, except that if you want to do a cool scatter plot, you want to change your colors and, for example, your marker sizes as a function of the data. If you wanted to do that with plot, you'd have to plot each marker independently. If you want to do that with scatter, you can essentially map the sizes of the data points and the colors of the scatter data points as a function of the data, or anything you want, really. But you can give this an iterable so that it can change the size, this is marker size, and the color, this is the color of the marker. Okay, so this is what it looks like. So here we see that the size is a function of the absolute distance from the y-axis. So the size gets bigger as we get further away from the y-axis, from 0 of the y-axis. And the phase is colorizing the data as the sine waves propagates. So the phase of 0 is always about blue, and the phase of pi is always about yellow. Oh, and in this plot, I've also done some LaTeX formatting, and because I wanted to show pi nicely here. I'll talk about this if we get to it, but it's just R before the string, and then a $, and then math mode inside the $. If you know LaTeX, you know how to put it into Matplotlib. Okay, so scatter plots are cool. The breakout is a scatter plot, but we'll see if we get to it. Okay, after scatter plots, histograms, another very important type. There's a built-in Matplotlib method to generate a histogram plot. It's just hist. It returns an array of the number of, I guess, the count in each bin, the locations of the bins, and then patches are the rectangles that it draws on the plot to create the histogram. Okay. So here, a very simple histogram. And to recall what setp does, we can make a Christmas-themed histogram. Yeah? Christmas-themed. So setp can take a list of patches and then change the color. So I took every even patch and changed the color to red. So histogram is pretty cool. You can change the number of bins that you want to do. Let's say we wanted to do 10 instead of 50 to get a coarser histogram. You can do that. And you can also specify exactly what the bins are that you want to use if you don't want to use regularly spaced bins by giving bins a list or an array. You can norm it, you can change the color, and you can also do a range if you want it to. Let's see, where does this go? Let's say 50 to 100 if we only want to look in that range of the data. This is distorted. Why is this distorted? Oh, it must calculate the x limits based on the data. But you can, of course, always do plot.xlim, 0 to 50. There we go. Thank you. Nobody's lost yet? Everybody's lost. But that's OK, because you can go back in the notebook and you can see how these do. And one of the themes of Matplotlib is don't create a plot from scratch, look at somebody else's plot, and see how they did it. So to make contour plots is somewhat easy, and I think pretty cool with some help from SciPy. So here we'll grab stats from SciPy, and we'll take color mapping from Matplotlib. And there's a lot of code, and it makes this plot. So the first thing I do is I create this data, which we will then plot as a scatter plot. So that's the one on the left. And it's a polar equation just converted into x and y. And I'm turning off the ticks. This is a convenient way to turn off all the tick marks in Matplotlib. And then to create the contour plot, I first create basically a Gaussian kernel density estimator using that SciPy stats. And this is not super important, but if you want to copy it, it's easy enough to copy. And then 128 by 128 array, essentially, called Z here, of the density of these scatter points after they've been smoothed by that Gaussian kernel. And that's what we see on the right-hand side. And you can change things like if you wanted to do reds, this is how the color mapping works. So there's a whole bunch of color maps that you can look up in a website that'll show you all of the Matplotlib color maps available and give you a nice little graphic of what they look like. OK, so contours. And I think I should be done very soon. If you want to put up text into a plot, you can do it with axis.setTitle, axis.setXlabel, YLabel. You've seen those. If you want to drop text in an arbitrary location, you can use axis.text. And if you want to annotate the elements in your plot, like the specific markers, you can do that with annotate. And then on the whole figure level, there's supertitle and figure text. And as I said earlier, you can do LaTeX formatting by just enclosing the LaTeX math mode inside $signs and then prepending the string with an R outside the quotes. And here is a plot showing all of those, pretty much all of those ways of adding text. So it makes an ugly plot, but you can refer to this if you want to say, oh, how do I annotate things? You just do it like this. You give it the location to annotate and some text, and if you want, you can add an arrow to annotating a position. OK. Questions? No. So I want to call this done. Are we have the next one ready? OK. Well, no, I'd rather skip to the breakout than this stuff. So I'm going to do that. So event handling is that cool things about interactive plots. You can do that if you want on your own time. It's cool. Image display is kind of cool. I'll just show you. You can show an image by doing imshow. And you can read in an image with imread. And there it is. And then once you have it as an array, you can start doing stuff with it. Oh, 3D plotting. Yeah, you can do 3D plotting too. We'll skip over that and get to the breakout. Oh, and the other thing I want to note is you can go to the Matplotlib gallery page, which is here. Why does this not work? Oh, well, that's not important. This is the URL to the gallery page. It's probably working in your notebooks. And it's a huge gallery of different plots. Go there, find a plot you like, learn about the source code, and modify the source code to make your own plot. Everybody says that, and after you've done that like 24 times, you'll get a good feel for the type of plots that you are most frequently producing. So the breakout. In the archive, there's a folder called data, and then stations.txt. I want you to read in that data. It's, I think it's a comma-separated value. So you can do that with, you can do it with pandas if you want, and then make a scatter plot of it. And after you've made the scatter plot, color code it using the elevation and the, what was it? It's redundantly elevation and yes. encode the elevation in the color of the scatterplot points and the size of the scatterplot points. And then annotate each station, each point on your plot, which kind of looks like a map of the Himalayas, with the 4-letter code, which is the station ID. So should we do this, or do you just want to skip ahead? Okay. So I will present. Well, there are 2 other much harder breakouts if you want to do them. I encourage you to do them on your own time. The answer for that scatter plot looks like this. Do you want me to show the code? Breakout. Where'd the breakout go? Oh, here it is. So here's the solution for number 1. First, we import Pylab, as always. And this whole code block here is the solution. First, we read in the data. We do it really easily using load.txt. And then I'm giving it a data type here so that we know that the first thing is a station of length 4 string. The second thing is a float latitude. The third thing is a float longitude. And the fourth thing is a float elevation. And then I'll create the figure and then add a super title to it just to make it look pretty. And add an axis using add subplot. And on that axis, I will plot the data by longitude and latitude. That's the x and the y data. And then to encode the size, I will do it as the data's elevation times 50, just to blow it up big enough. And I'm adding 1 here because that way there's a basically a lower limit to the size of the data points so you can see them all. And then the color map, I'll just encode it directly on the elevation data using the default jet color map. And this will go and convert the array of elevations and map it into the 0 to 255, well, it's a float, but color mapping. And then for each station's annotation, we loop through all the stations and annotate based on their x and y coordinates in the grid. And we'll give it as the string the station ID, which was loaded in from that load.txt call. And then you can give the text a offset from the data. So I do that here, and I do it a little bit smartly because the higher stations in elevation are going to have bigger circles around them. So I want the annotated text to be a little bit further away. So I use the elevation as a variable in computing the x and y locations for the actual text. Give it a font size. And then to slap the color bar on there, it's as easy as calling just variable name equals plt.colorbar and then sc, where sc was returned from our scatter plot. So the scatter call on axis returns the object sc, throw that into the color bar, and that'll put the color bar on there. And that's it. And you make the plot. Cool.
So we can do some questions while we're setting up, but for those that are in the other 2 rooms, if you could find your way down into the main auditorium, there's plenty of seats here because we're going to now set up for the industry panel, and it should be very interesting. I hope this is quite interactive. So I think it'll be just easier if you're all down here. But you have about 10 minutes or so before we get started. So please stretch your legs. And a reminder that we will have a social event immediately after the industry panel upstairs and outside. So I hope you stick around.
2, 1, 2. Hey, hey, 1, 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 2. Huh? They're getting it in there? Hey, hey, 1, 2, 1, 2. 1, 2, 1, 2. Hey, hey. Hey, hey. Is it not playing in here? Hey, hey, 1, 2, 1, 2. Hey, hey, 1, 2, 1, 2, 1, 2. Hey, hey, 1, 2, 1, 2, 1, 2. Hey, hey, 1, 2. Okay, hold on for a second. Let me check my send. Check, check. 1, 2, 1, 2, 1, 2. Hey, hey, 1, 2, 1, 2. Hey, hey, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2.